Okay, let's talk about the quotient property of square roots. To divide square roots and simplify radical expressions, you can use the quotient property of square roots. So for any real numbers a and b, where a and b are both positive, the square root of a over b is equal to the square root of a divided by the square root of b. Just like you can break apart multiplication of square roots, you can break apart fractions of square roots. You can use properties of square roots to do what's called rationalize the denominator of a fraction with a radical. This involves multiplying the numerator and denominator by a factor that eliminates radicals in the denominator. So when a radical is fully simplified, it contains no perfect square factors, has no fractions in the radical, and there's no radicals in the denominator, okay? So for example, which expression is equivalent to square root 35 over 15? So let's use the properties here. So 35 over 15 just reduces to 7 over 3, okay, square root 7/3. Now there are no perfect square factors in 7 or 3, but I can use the quotient property of square roots to rewrite it as a square root of 7 divided by the square root of 3. Now, I got rid of the fraction inside the square root, but I still have a square root in the denominator, so it's not fully simplified. Notice that your answer choices none of them have a square root in the denominator. So what do? I multiply by square root 3 over itself, because square root of 3 divided by square root of 3 is essentially equal to 1, and when you multiply a problem by 1, you're not changing the problem. I'm not changing the value of the problem, I'm just changing the way it is expressed. And the reason I'm multiplying by square root of 3 over the square root of 3 is because in the denominator, those square roots multiply together to give you square root of 9. All right, which simplifies to 3. So this step, let me just write it out, would be square root of 21 over square root of 9. And square root of 9 is a perfect square, which simplifies to 3. So it's 21 for square root 21 divided by 3, okay? Now you can't divide that 21 and 3 and get 7 because this 21 is trapped inside the square root, so you'd have to take the square root of 21 first before you would divide by the 3, okay? Which the correct choice is B, all right? Here's one for you to try. Go ahead and simplify the square root of 6y over the square root of 12. Go ahead and pause the video. Okay, we're back. So here's a couple things you could do. You could rewrite it as one single square root like this. And here's why. Because the 6 over 12 reduces to just y over 2. And then you'd have square root of y over square root of 2. And then you can rationalize the denominator by multiplying by square root 2 over square root 2. So then you'd have square root 2y over square root 4, which is square root 2y over 2. And the correct choice is H. Okay? All right, so that's rationalizing the denominator to get rid of the square root in the denominator. Okay? Binomials of the form a square root b plus c square root d and a square root b minus c square root d, where a, b, c, and d are rational numbers, are called conjugates. So for example, 2 plus square root 7 and 2 minus square root 7 are conjugates. The product of two conjugates is a rational number and can be found using the pattern of difference of squares. So do you remember when we did a minus b times a plus b? And you FOILed it out and you got a squared plus ab minus ab minus b squared. And the middle terms cancel and you just got the first term squared minus the last term squared. Same exact thing here. Conjugates are binomials who are exactly the same except that the sign in between the two terms, one is a plus and one is a minus. Okay, well, that's very, very helpful when simplifying radical expressions. We can use conjugates to simplify the denominator when you have a binomial in the denominator that has a square root in it. So for example, in this one, you can't just multiply by square root 2 over square root 2. Because if you did it right, you'd have 3 square root 2 in the numerator. And this square root 2 has to actually distribute, that should have been a plus, to both of those. And then you'd have 5 square root 2 plus, well, this would give you square root of 4, which is 2. Now you have the square root of 2 over here. It's still square root 2 in the denominator. And then I can multiply by square root of 2 over 2 again. And it would just keep repeating, and every time it would either be over here would be a square root or over here would be a square root. And you just make the problem more complicated. So what we do is multiply by the conjugate of the denominator. So if you have a binomial in the denominator that has a square root in it, multiply by the conjugate. And all you do to make the conjugate is just change the sign in between. So it was 5 plus root 2, now it's 5 minus root 2. But again, you have to multiply by the conjugate over itself because that is essentially equal to 1. So we're not changing the value of the expression, we're just changing the appearance of it. Okay? So the numerator, I like to put parentheses around everything. Okay? Because the numerator, the 3, is going to actually end up distributing to the 5 and the root 2. And when you multiply conjugates, all you do is get the first term squared, so 5 squared, minus the last thing squared, square root of 2 squared. So the 3 distributes and gives you 3 times 5 is 15, and 3 times square root of 2 just gives you 3 square roots of 2. The 3 doesn't multiply into the square root, okay? It doesn't become square root of 6 because the 3 doesn't have a square root over it, okay? It just becomes 3 times square root of 2. Then 5 squared is 25 minus the square root of 2 squared. So when you square square root, they cancel out and you just get 2. Okay? So that simplifies to 15 minus 3 square root of 2 over 23. All right? Here's a couple for you to try. Go ahead and pause the video. All right, we're back. So the first one, the conjugate is formed by multiplying by 2 minus square root of 2 over itself. I like to put parentheses around everything. So the 3 distributes, and you would have 6 minus 3 root 2. And when you FOIL this out, basically it becomes the first term squared minus the last term squared. So you'd have 6 minus 3 square root of 2 over 4 minus 2, which becomes 6 minus 3 square root of 2 all over 2. That's your final answer. All right. This one, the conjugate is formed by just changing the sign. So it's going to be 3 plus square root 7 over itself. All right, parentheses around everything. And then distribute the 7. So I'd have 21 plus 7 square root 7. You FOIL the denominator, it becomes the first term squared minus the last term squared. So it'd be 21 plus 7 square root 7 over 9 minus 7, which would be 21 plus 7 square root 7 over 2. Okay? All right. Well, that's it for this section, guys. Please continue on to your assignment. Reach out to me if you need any help. And as always, take care.